I'll be showing you SAP HANA Studio, and at the end we'll be doing an exercise on SAP HANA Studio. But before we delve into the details of SAP HANA, I would like to shed some light on the background, which currently all the companies are having massive amounts of data. The data is growing daily, and it's very tough to efficiently report on that data due to its volume. And as you know, all the business critical decisions are made on the basis of these reports. So, a way is required to handle this massive amount of data. Secondly, the companies want real time access to the data to help them analyze and take the right decisions or action instantaneously. Real time means that you can execute the statements at the same time as the new data keeps rolling in. So, a way is required to accelerate the data processing by many factors to analyze and process this humongous amounts of data in real time. It should be instant. So, what is SAP HANA? HANA stands for High Performance Analytical Appliance. Now, with this SAP HANA, massive amounts of data can be managed, it can be analyzed at a very high speed in real time. So, with SAP HANA now, both OLTP and OLAP applications can use the same HANA database. SAP HANA is a modern in memory database and platform that's deployable on premise or in the cloud. By modern database, this means that HANA is not like other traditional databases, but it's a newly designed with column and row store architecture, and it's optimized to make use of parallel processing capabilities of the modern multi-core CPU architecture, wherein multiple CPUs are on one chip. So now the servers can have 2 terabytes of system memory, which makes it possible to have the complete database in RAM. Due to multiple cores in the server processes and the very fast communication between these processor cores, now more data can be processed in parallel. Now a report can run around 3000 times faster with SAP HANA. By in-memory database, this means that the complete data stored in HANA database resides in memory. Now, no more disk input-output bottlenecks are there, and the whole processing is in memory, which can access the data 10,000 times better speed with the better speed as compared to the disk. So there is no time wasted in loading the data from the hard disk to RAM, or while processing the data, keeping some data in RAM and then some data on the disk. Now everything is in the memory all the time, which gives the CPUs quick access to data for processing. So the speed advantages offered by this RAM storage system are further accelerated by the use of multi-core CPUs. As I already told you that there are multiple cores per CPU, and there are multiple CPUs per board and multiple boards per server. So you can just imagine that how fast the processing can be. So you must be also aware about that the fact that memory is volatile. So you may think that what if you have loaded all the data in the memory and the power goes off? So for that, SAP HANA has a safety net which ensures the durability of the data. That is, the persistency layer is there. So you do not need to worry about the volatility of the data of the memory. So SAP HANA is a platform which integrates number of SAP components including SAP HANA Database, SAP HANA Studio, and SAP HANA Client. As an appliance, SAP has partnered with leading hardware vendors like HP, Fujitsu, IBM, Dell to sell SAP certified hardware for HANA. These are the hardware partners who are the certified vendors that offer hardware on which SAP HANA software can be installed. So, SAP is selling licenses and related services for the SAP HANA product, which includes the database, the HANA database, HANA Studio, and other software to load the data in the database. So, what is SAP HANA platform? The SAP HANA platform is a flexible data source agnostic in memory data platform that allows customers to analyze large volumes of data in real time. So it's a flexible data source agnostic. What do I mean by that? That means that there are many use cases in which HANA can be used today. In fact, HANA presents itself as a cloud company powered by HANA. So SAP integrates HANA into pretty much everything. It's quite flexible. By data source agnostic, this means that the data does not have to come from only SAP sources, like from SAP Business Suite's applications like ECC, CRM, or BW, but it can also be sourced from any non SAP sources like Teradata, DB2, Hadoop, or even Twitter feeds. And it's able to analyze large volumes of data in real time. Now you can perform your business intelligence on humongous amount of operational transactional data as it's rolling in. That means it's real time. As soon as the transactions are punched, it's available for reporting. Now no need to calculate and build aggregates. It's all real time. And it's also a development platform which provides an infrastructure for high performance applications based upon SAP HANA Extended Application Services. We call it XS also. There is an XS engine which helps in this. So now we'll be covering SAP HANA Studio. I'll be showing you how does it look like. The primary SAP HANA application development tool is SAP HANA Studio, which is a client software based on Eclipse, which you use to connect to HANA databases. Eclipse is known as a world-class IDE, that's integrated development environment. So SAP HANA has leveraged many of its powerful features. So SAP HANA is delivered in the SAP HANA appliance, and it enables the technical users to manage the HANA database. It enables them to create and manage user authorizations, to create a new or modify existing models of data. Or in other words, we can say that SAP HANA Studio provides an environment for administration, modeling, development, and data provisioning. So let me just shift to SAP HANA Studio. This is the SAP HANA Studio. And when you start SAP HANA Studio for the first time, there'll be no connection to SAP HANA system maintained yet. So first of all, we need to register a new system for the connection to the SAP HANA database running on some other machine. So in order to connect to a SAP HANA system, we need to know the server host ID and the instance number. And we add the system from here. As we are working on the cloud system, so we can add cloud system. We can choose this option. And here these are the credentials provided by the cloud environment, and these are my credentials, and I'll be logging in. The account name and the username and password. We need this username and password combination to connect to the instance. So the instance provided by SAP HANA is dev. So I'll just connect to it and click on finish. Now it's adding the SAP HANA cloud platform system. So on this left side navigator, this space shows all the HANA systems added to the HANA Studio. Right now, we have just added one HANA Studio, HANA system. So it's showing this one. So let me just give you an overview about all the different perspectives. Then we'll start working on HANA Studio. So when you start the SAP HANA Studio for the first time, you can decide on several perspectives. So what are perspectives? Perspectives are the predefined user interface layouts, or you can call them views also, dedicated for different roles. So from here, there is an option to open the perspective. I'll just show you. These are all the perspectives. These views basically here you can see different views, like not here, these are the perspectives, but if you select a particular perspective, then there will be certain views on the screen. So like here we have this properties view. Right here we have this problems view, we have this history view. So these are all the different views in the these are the basic screen elements, and a collection of these displayed views combined with their placement within the screen builds a perspective. So when you open a perspective from here, you can see different types of perspectives. Like we have this SAP HANA modeler. This is the perspective which is used by data architects to create information models. It's for a modeler, and it provides the views and the menu options that enable you to define your analytical model. For example, attribute views, analytic views, and calculation views. All these views can be created from SAP HANA Modeler. Then we have this, we have different views. So we have one debug view as well. Here you can see debug view, debug perspective, I'm sorry. So this perspective provides the views and the menu options. All the views and menu options are specifically meant for certain perspectives, so they keep on changing. So for the debug perspective, it allows all the menu options and the views options that help you to test your applications. For example, to view the source code, or to monitor or modify the variables, and you can set the breakpoints and all sort of debugging from this perspective. Then we have this SAP HANA administration console, which lets you administrate the SAP HANA instances depending upon, of course, your user rights. Then like this, we have SAP HANA development perspective, the most important one. Here you can see all the systems which have been registered. I'll just show you. We have, yeah, only the from here also we have this SAP HANA modeler perspective. You can see here the SAP HANA modeler perspective. These are the different views for the modeler perspective, and for development perspective, this is the view. Okay, so in the development perspective, we have these three navigation views. One is the project explorer, then is the repositories, we call it SAP HANA repository, and then we have this systems, we call it navigation view as well. So in the project explorer, it shows the projects on the local file system. In the SAP HANA repository, it shows all the contents on the HANA server, right? The project explorer deals with only your local machine, whatever is on your local machine, all the contents, all the projects on the local machine, it just shows that. But this tab, the HANA repository view, shows you all the contents on the HANA server. And the next is the systems tab, that's the navigation view, where you can see all the added systems. As we had added this system, so we can see all this system here. Otherwise, if you add more systems, you'll be able to view all the systems. So here you can see the catalog folder which contains all the database schemas which will be automatically created when a user is created. So I'll just show you all the schemas. You just expand it. These are all the schemas. In SAP HANA, only physical tables actually carry the data, and all the information models created in the modeler are saved as database views only. So if you just expand this node, and you'll see a list of schemas which are used to categorize tables according to customer defined groups. That means that these schemas are used to group the tables into categories which have some specific meaning to the user. So each schema contains a folder for, I'll just expand all the schemas so that you can see. All these schemas contain a folder for column views, for procedures, sequences, synonyms, tables. So the schema with your username is the place where you can actually create all the objects and modify them. In rest of these schemas, you can only use their objects, you can only consume their objects, but you cannot modify or delete them. So my system's name, my username is this, so it belongs to me, this particular schema. I can just view all these schemas, all the contents of these schemas, but I can create the table, all these things over here, all these objects I can create in my own schema. So then we have the content node, which is again a very important node. It displays the data from a data modeling perspective. That means it represents the design time repository which holds all the information of data models created with the modeler. So physically, these models are stored in database tables, which are also visible under the catalog from here. The contents node here, it just provides a different view on the same physical data. These are just views. It does not contain physical data. The physical data lies only in the catalog folder, and these are just the different, you can say, view of that physical data. And all these information models which we create in the content folder, these are organized in packages. So like in this package, the user can create, if I right click on this, I can create this attribute view, analytic view, and calculation, all sort of objects over here, these views over here. And these are basically organized in the package, in this package. And then we need the delivery units which are used to transport these packages. So these are the two main nodes in the under the system. So now I'll show you how do we create a table in SAP HANA database. So to create a table, it must be sure that you have SAP HANA Studio installed on your machine, much obvious, and you have added a SAP HANA system in HANA Studio. So to create the table, as I told you that we can only create the table in our own schema. So this is our schema. As we are going to create the table, so we have to click on the tables folder. Then just right click on the tables folder and select new table. If you have worked on RDBMS, maybe even Oracle or SQL or whatever, you must be clear about the fundamentals of the table, that there is a primary key in a table which is used to uniquely identify the records, all the records in the table. So we'll also keep one primary key over here in our table. So I'm going to create a table for managing the product details. So I'll just for the name of the table, I'll choose product, right? And this is our schema. You can see over here the name of the schema. And now this is the most critical part, or I would say most important thing, that is what's the type of the table. whether it's a column store type, it's a row type, or whether you're creating just a table type. So right now it's I would take this opportunity to give you an overview about this row and column store. So the SAP HANA database is a hybrid in-memory database that combines row-based, column-based, and object-based database technology. So the SAP HANA database allows the developer to specify whether a table is to be stored column wise or row wise, or whether you are creating an object type, that is a table type, as you just saw over here. It it allows the developer to choose the type, right? So it's also possible to alter an existing table from columnar to row based and vice versa. So, without digging very deep into the row and column based concept, just to give you an overview, that you must be aware that the computer memory is organized as a linear structure. So, to store a table in linear memory, two options exist. One is the row oriented storage, which stores a table as a sequence of records, right? Which is always there. You must have seen all the traditional databases. All the traditional databases, they support this row oriented storage, where it stores a table as a sequence of records in the memory, and each of which contains the fields of one row, right? But now in SAP HANA, we have another option, that is the column storage, wherein it stores the table records in a sequence of columns. That is, the entries of a column is stored in a contiguous memory locations, right? So earlier it was a sequence of rows, and now it's a sequence of columns. Now it stores in the linear memory as a sequence of columns. So this gives great benefits. It gives us faster data access, better compression is there, better parallel processing is there, because in column store data is already vertically partitioned. So this means that operations on different columns can easily be processed in parallel. So, if multiple columns need to be searched and aggregated, each of these operations can be assigned to different processor cores. So, here comes the multi core capability also. So, that way, this column store and multi core, these two things have. We have combined They have combined these two things together to get the maximum parallel processing capability. So this is just here. From here you can decide that whether you want the data to be stored as row or the column. See, in case of analytical applications where aggregations are used and fast search and processing is required, their row based storage is not good, right? In row based storage, all the data in a row has to be read, even though the requirement may be to access data from a few columns. So the queries on huge amounts of data take a lot of time. Row based storage is good for writing the records. So in if you choose column type, then this information is stored physically in columnar tables next to each other. All these information which is required for aggregates, so which significantly increase the speed of certain data queries. So it's most useful for OLAP queries, where the queries are using aggregate functions, because these queries get just a few attributes from every data entry. But when you are dealing with traditional OLTP queries, where which are not using any aggregate functions, then it's always more advantageous to store all the attributes side by side in the row tables. So SAP HANA combines the benefits of both row and column storage tables. So now I'll be creating first the row store table, just to give you an example. So here in the product table, we have the primary key, that's the product key, and we'll choose the length to be 5, and its data type is varchar. Here you can see various data types. You must be aware about the different data types. This is for storing integers, for ASCII code, for Unicode, for time data, for binary data. So these are the different data types to store different kinds of data. So it's just a character string, so we'll be using varchar. Next, to add the new column, click on plus, and here you can write the name. This is next column is the name, and I would choose it to be 25. And next is next column I would choose to be color, right? And the color maybe 15 are required. And then is the fourth is I'll write size here, the fourth column, and size, let's choose the size to be of integer type. Okay, and then I think that's enough for testing. It's enough. So after providing the name of the columns and after providing the data types and their lengths, here you can provide that it's a primary key, right? And if you want to give some default value, you can give over here. Then that default value would appear by default for all the rows, and this is the field for some comments. So now to create the table, you need to click on execute. That's it. And now it's successfully created. You can see over here it's successfully created. So to see the definition, now let's it should appear over here, right? So let's refresh it so that it appears over here. Yes, it's appearing. Yeah, you can see over here. And now we can see the definition on by right clicking, choose open definition. There its definition will appear. This is the definition, right? Now I want to show you the procedure is same to create the column store table also. So I'll just create, just a second. By mistake I opened the editor. Basically now it's open, so I can explain it to you that you can create you can use the SQL commands also to create the table, to insert the data. So it was the editor from where we can put the SQL statements. You can just execute those SQL statements from here, like insert into table this, values this, or create table. You have to write the syntax for that. So yeah, I was telling you about the column store table type. So the procedure is same. You just need to create the table and choose column type over there in the place where we need to choose the table type. From here you just have to store the column store. You just have to choose the column store. So if you just let's keep the name of the next table as reseller, right? So let's keep it as column store. Let's keep the reseller key as the primary key, and it should be 3. And then let's keep only 2 values, its name, just to keep it short. The name should be around 25 characters. That's enough. Now let's execute it. It's as simple as that. Now it's you can see here it's successfully executed, and now you need to refresh it to just let it appear over here, right? You can see over here that the icon is different for column store and for row store. It's horizontal and it's vertical. That shows that it's a column store and it's a row store. So now to put the values, to insert the values, you just need to right click and choose generate and choose insert statement. See this, now the editor is opened and the same statement I was talking about, insert into this is the name of the schema, schema dot your table name which you have created, and the values. Here you can provide the values, like I want to provide 1 and maybe shoes, and next it was the color, right, white. And see, you can see over here there are the quotes for the character values, and because the last column we had kept as integer, so there are no quotes. You must be aware about these fundamentals if you have worked with SQL. And now let's execute it. You can see over here it's successfully executed. Now to check it in the table, let's right click on the table and generate and select statement. You can see it again, it has opened the editor, and this is the SQL statement. Very simple. You can just write it or you can go through the menu, and you have to now execute it. That's the table. It's very simple. Now if you want to insert multiple values in one go, you just need to choose insert statement here and to maybe sandals, black, and size 8. And here you need to press put semicolon. Okay, to put multiple values, to execute multiple insert statements, we need to, just a second, yeah, we need to put semicolon and then we can execute multiple statements. Now we'll just quickly change the values. No, let's not keep this. Okay, now we can just keep the product is sole black 8, and this can be maybe 9, and for that its units must be there, right? When you are now I'm choosing the size as 9, so what's 9? It may be 9 centimeter or something like that. So we'll have to, this is just for example, so that's why I have not included the units also. Otherwise if we include the size field, then there must be some column to save the unit of that particular column of that particular size. Okay, so let's just execute it. You can see here it's successfully executed, and now let's just select the data. Now this is again the select statement, and you can just execute it, and here there is the data with you, the one which you had inserted, and the same way you can insert the data in this table. So that was all for now. I hope all the perspectives and how to create a table and how to insert the value, these logics are clear to you, and in the next session we'll do about the contents. We'll be creating the analytic views or attribute views or calculation views. So we'll be working upon that. So that's all for now.